time an intriguing concept we live with every day, but have you ever wondered, will it ever end? Time, it's the unseen fabric that weaves our existence together, the silent rhythm guiding our lives from birth till death. It's the very essence of change, the force that turns the raw potential of the future into the fading memories of the past. Yet, as fundamental as time is to our existence, it holds a mystery as profound as the cosmos itself. Will time, this relentless march forward, ever come to a halt? Is there an end to this infinite spiral, a point where the ticking of the cosmic clock ceases? From the farthest reaches of the universe to the smallest particles within us, time governs all. But what if one day it simply stopped? The thought is as fascinating as it is terrifying. Let us explore some fascinating theories that predict the end of time. Imagine a universe expanding indefinitely, leading to a state of maximum entropy. This is the chilling prospect of the heat death or big freeze scenario. Here, the universe, driven by its incessant need to expand, reaches a state where all energy is evenly distributed. As this happens, temperatures across the cosmos begin to plummet, inching closer and closer to absolute zero. This frigid state is not just a big chill for the universe, but a freeze frame for time itself. Picture the universe as a clock, each tick representing the movement of energy. But when energy becomes evenly spread, there's no movement, no tick, no talk. The clock of the universe simply stops. In such a universe, all processes halt. Time effectively ceases to exist. It's a vision of the future that seems stark and cold. But remember, this is just one of many possibilities in the enigma that is the fate of our universe. What if the universe's expansion reverses due to gravitational attraction? Let's delve into a theory that propounds this possibility, known as the Big Crunch. According to this concept, the universe's expansion, which has been ongoing since the Big Bang, could eventually reverse. This turnaround would be due to gravitational attraction, a force that binds everything in the cosmos. The Big Crunch paints a picture of all matter collapsing, drawn inexorably back to a singularity, a point of infinite density. This singularity, a concept that challenges our understanding of physics, is where the laws of nature as we know them cease to apply. But here's a twist. This collapse could potentially trigger another Big Bang, birthing a whole new universe, a new epoch of space and time. However, the Big Crunch would also mark a profound endpoint. This collapse marks the end of time as we know it, a grand finale to the cosmic symphony, and perhaps, just perhaps, the overture to another. Consider a universe where expansion accelerates, tearing apart all matter. Picture the cosmos, once brimming with galaxies, stars, and atoms, succumbing to a relentless force. This is the premise of the Big Rip hypothesis. This theory suggests that dark energy, an unseen force driving the universe's expansion, could grow stronger over time. As it intensifies, it would start to overpower gravity, the glue holding galaxies together. Slowly but surely, galaxies would be torn asunder, stars ripped from their orbits, and planets would disintegrate into cosmic dust. But the Big Rip doesn't stop there. Ultimately, this insatiable force would reach into the very fabric of matter, pulling apart atoms themselves. The universe, once a symphony of matter and energy, would be reduced to isolated particles floating in a vast, expanding emptiness. In such a universe, the concept of time loses all meaning. Without matter, there can be no events, no change, no time. As matter disintegrates, time ceases to exist. Could time itself decay at a fundamental level due to quantum mechanical effects? Now, let's delve into this intriguing concept. Picture time not as a constant, but as a thread woven into the fabric of reality that could potentially fray and unravel due to quantum mechanical effects. This is quite a departure from our conventional understanding of time, isn't it? Quantum mechanics, the theory that describes the behavior of particles at the smallest scales, is riddled with counterintuitive phenomena. It suggests that particles can exist in multiple states simultaneously, or teleport through barriers. So, could these strange quantum effects cause time to decay? Some theorists propose that quantum mechanical decay could lead to the gradual disintegration of time. Each tick of the clock might become less and less meaningful until time loses its structure entirely. This could result in time's eventual cessation. The implications are profound, challenging our understanding of the universe and our place within it. In a multiverse where time may persist indefinitely in some regions, what happens to other regions? This query propels us into the mind-bending models of the multiverse and eternal inflation. Here, the cosmos is not just a single universe we're familiar with, but an unimaginable expanse of many universes or bubbles. Each of these bubbles could house different physical laws, histories, and futures. Now imagine these bubble universes inflating eternally. Some bubbles expand, creating endless space and time, while others might collapse or decay. This is where the concept of localized ends of time comes into play. Instead of a universal conclusion, each universe might meet its own unique fate, its own end of time. A bubble universe could reach a maximum state of entropy, or perhaps collapse under its own gravity. The possibilities are as diverse as the universes themselves. And so, in such a scenario, the end of time would be localized rather than universal. Quantum mechanics and string theory propose intriguing possibilities for the end of time. These two theories introduce concepts that may seem like they're straight out of a science fiction novel, but they're grounded in real, albeit complex, physics. Quantum tunneling, for instance, suggests a fascinating phenomenon. In the realm of quantum mechanics, particles have a certain non-zero probability to spontaneously move from a high-energy state to a lower one, even if there's an energy barrier in the way. This is akin to a ball suddenly appearing on the other side of a hill without having to roll over it. Now, imagine this happening on a universal scale. The universe, as we know it, could tunnel into a lower energy state. This event could trigger what's known as a phase transition, fundamentally altering the structure of space-time itself. The universe as we know it might collapse, only to be replaced by a new universe with entirely different physical laws. In essence, the clock of the universe could get reset. On the other hand, string theory brings us the concept of Brane Collision. String theory proposes the existence of multiple dimensions, or branes, that exist alongside our own. Picture these branes as giant multidimensional sheets floating in a higher dimensional space. Now, what if two of these branes were to collide? The result would be a cataclysmic event that disrupts the fabric of space-time. The universe could collapse in such a collision, potentially giving rise to a brand new universe or leading to the end of time as we know it. These theories, quantum tunneling and Brane collision, paint a picture of a universe far more dynamic and potentially transient than we might otherwise imagine. They suggest that the universe and time itself could undergo fundamental changes, leading to new beginnings or abrupt endings. Such events could lead to the formation of a new universe or the cessation of time altogether. In the grand scheme of things, our understanding of the universe and time remains ever-evolving, and these theories continue to challenge and expand our perceptions of reality. Could our universe exist within a simulated reality that could be shut down? A tantalizing thought, isn't it? This is the heart of the simulation shutdown theory. It speculates that our universe, with all its complexity and grandeur, could be nothing more than a sophisticated simulation designed by a higher dimensional civilization or advanced beings. Imagine, if you will, a cosmic game where the rules of physics are nothing more than programmed algorithms, stars and galaxies mere pixels, and time itself a coded construct. The implications are staggering, raising profound philosophical questions about the nature of reality and our place within it. But what happens if the game ends? If the simulation is terminated, what becomes of our universe? The answer, according to this theory, is as simple as it is unsettling. If the simulation ends, so does time within our simulated universe. A sobering thought indeed, as we ponder the mysteries of time and the ultimate fate of our universe. As we have seen, theories about the end of time are as diverse as they are fascinating. From the chilling prospect of a heat death or big freeze, where the universe gradually winds down to a state of maximum entropy, to the dramatic big crunch or big rip, where the cosmos could collapse or tear itself apart. We've delved into the quantum realm, where time might decay or change fundamentally, and considered the possibility of a multiverse, where time's fate could vary from region to region. We've contemplated the mind-bending concepts of quantum tunneling and Brane collision, which could reset or disrupt our universe. Lastly, we've ventured into the realm of the speculative with the simulation shutdown theory, questioning the very nature of our reality. Each of these theories offers a unique lens through which to view the ultimate destiny of our universe and time itself. Please subscribe to Deep Space for more intriguing explorations of our universe.